Welcome, I'm Bill Wake. We're here working on a programming language called Tenth that's sort of a fourth imitator or a fourth subset or altered fourth subset or something. And we're doing the interpreter and working on an assembly language to do that. Now I made some changes. The big one is I switched over to Xcode because I saw somewhere you can use that. I think the editor is a little less annoying than TextMate has been. TextMate was really bad about throwing in extra tabs and putting them in when I didn't expect it and deleting them when I didn't. So we'll try this for a while. Editor number 3 or 4 in a couple weeks. The other thing is after we met, I did some studying. One thing was I found old assembler documents for the Mac assembler. It looks a number of years old. I don't think it applies to the current version, but it gives something. I also finished downloading that ARM documentation, the architecture manual. It turns out it's over 6,000 pages, which is why it took so long to download. And then MudShark666 proposed this on the way out yesterday, but his suspicion is we got the bus error because our ASCII Z is not putting things on a byte-aligned boundary, which our other work needs. Okay. And then the next thing I did was I went through the branches because it just seemed like, so there's branch label, which is just a plain old go-to. BL label, which is the subroutine call. It sets the LR link register. And then there's also, this is the one I wasn't sure, I didn't think to use yesterday, but BLR is like BL, but it lets you call the address from a register. And I think that's the one we need, where we had BR register in there, which only branches and doesn't push. So, it doesn't set the frame counter or link register. And then there are a couple other instructions. Compare basically compares to 0 or to a register, and then you can branch conditionally with b.eq, b.me, etc. And a bunch of conditions that we haven't tried yet. All right. So I think I got things back to normal. Let's do make clear. Make clean. And make. Should run our tests and blow up on one of them. Okay, there's that bus error. All right, so first thing is let's deal with that. So we're in core. I'll get this over here. And we had core tests somewhere. Okay. And we have our real code in our tests for now. All right. So this is for the test. This is, no, we want interpreter tests. Okay. That's our test runner, such as it is. This is what we're working towards. This is where I think it should be a BLR. But the point was, let's find our test. Okay, interpret. We load empty because that's the pointer to the starting address. So our secondaries are a word that has the full address of the start routine, a bunch of single statements, kind of one per each, and then at the end it must call N2D, or again it puts the address of N2D and it gets called in directly. Okay, but the claim was that this is probably not on a right boundary. So I think that should help some, but I think it's the ASCII Z. Well, what I've done other places is this. So I'll put 5 and then ... to fill it out. And I think, what's going on there? I see. All right. So I think this will give us what we want. It'll still not work, but it'll be hopefully not complaining about the bus error, but just not working for some other reason. Okay, well, there's still a bus error. Okay, well, let's do it the other way. Let's do a .v2 align 2. No, we're still getting a bus error. Okay. Well, I suspect that was a problem. But let's... All right, so the interpreter is going to fill up the data stack. It's given, I guess we should write this in, right? Run interpreter is the startup method for the interpreter. Input is x0, which is the address of the well, they call this word address in some of the Forth stuff. The word address starting here. I think that'll be okay to use that terminology. Okay. And then output, x19 is the data stack. x20 is return. Oh no, it's the virtual stack pointer and the position in the current, I guess we'll block, I don't know, right word, current block, and this is our virtual PC. Okay. So I think, well, what Start2D should do, oh no, this should be the BLR x0 and then return. Okay, so we'll set up the stack, we'll set the virtual PC one past the block pointer. I'm not sure that's quite necessary. Actually, I don't know that we need to do the I'm not sure. Okay, well, all right. So we load this, we load that. I think we're supposed to save that in here more than anything. Not increment it. We're going to branch to subroutine pointed to by this value, which in our test we set, we store Start2D in this +8. Does that seem right? Oh, sorry, we store it in x0 and then add 8, so we're ready to store it in store x2 in the next one. So initial one should say Start2D, End2D with the address pointing to those routines. Okay, I believe that's right. Then we load the pointer to the word address, call our interpreter, and that's what we're testing. It sets up these two. It jumps indirectly to here and adds to our stack, but somewhere is blowing up. Okay, I think we're better off to find out where that is. I I'm not sure if I made any changes, but we'll just rerun it. Okay, and now we'll run it with LLDB. And this is interpreter tests.out. Run. Allow. Okay, and it blows up interpreter test out data stack 3E181. Oh, this is actually good. Okay. Question is, where is it blowing up? Data stack plus 10116. Well, here's this address. Okay, somewhere I have... Oh. I think I lowered it. This. All right, I guess I got to have this on the left. Sorry. Is that covered? No. Okay. This is our object dump. Interpreter test out. Okay, so somewhere like this, maybe this is an address we can find. Well, no. Okay, I think that must be the data segment then. Data stack plus 10. Let's take this and convert it just to make sure. I don't know, that doesn't seem like anything. Oops, that should be 16. Base 10 is 65558. Suspiciously close to 655, whatever, 65536. Yeah, that seems high. I mean, I put 10,000 in for our data stack size, but it shouldn't be at that end of things. I don't think anything's touching that stack pointer yet. All right, so I did this the other day. I have a cheat sheet somewhere. Okay, well, I can do register read. Yeah, that's a good one. What was thread backtrace? BT. Oh, well, data stack after this, let's see. So our data stack is here, 10,000. If that's a decimal, then that's somewhere down like this. If this is 10,008, or let's say that's 0, then this is 10,000, 10,008, 10,016 is this address. Now 6720. Oh no. Okay, let's do read. Okay, so X0 is pointing at data stack plus 10016. Now, why are these names? Oh, they're L names. Oh, well, let's, for this purpose, let's uncomment this. And try again. Okay, so, oh, well, X1 has start 2D, X2 has end 2D. That's kind of promising. I mean, at least that stuff we were attempting to put in those, the test does. All right. Well, quit. Yes. Make. Whoops. Oh, yeah, you can't just use... Can't just change it. even though I probably want to put it back in the long run, but just to keep ourselves sane when we're reading things. I don't think anybody references that. Okay. All right. Okay. So I think we can break I forget what it is. It's break set minus D. That. Oops. Is it N? N might work. Minus B. Whoops. Okay, so break set minus B run interpreter. Okay, so that's good. Let me put that in my little cheat sheet here. Yeah, this, let's make it B function, well, label. Because that does work in assembler. Okay, now we'll run, and if we get this far, we've made it to our interpreter. And we don't. Sorry. Stop reading is breakpoint. Okay, we do. All right. Okay, and then let's do reg read. I think I can just put the register. Well, let's just look at them all. There's stuff in there. Okay, so X0 still has empty. So in our interpret routine, we're only looking at X0. These are just junk as far as we're concerned. X0 through X7 are totally callee owns them. So if there's junk in there when you get in there, like some sort of allocator was running before we got involved. Okay. Good at some level. Okay, so we're here and we are pointing to empty. So that 10,016 really was the address of the empty storage. All right, let's find interpret, run interpreter. Okay. And let me set the background on this to a different actually maybe this one. I don't know. Silver sounds tolerable. I don't know how do I make it apply. Nope. Oh, new window. Okay, let's try this. Well, that didn't do it. Okay, I'm not going to waste time. Okay, run interpreter, add ERP. So we're loading the stack pointer with the address. Well, I'm going to have to look with the data stack. Okay, and 4,000 looks nice and even, so I think that's probably okay. All right, now I think we can just say step. So we're ready to run the ADRP. We'll do step. All right, and then reg read X19. is now data stack. Okay, that seems good. Okay, x20 pound 8. Okay, let's look at x20. 0 empty. I don't know that x20 should be there, but okay. Reg read 0. Okay, so if we do a step, we should see x20 should be the same as 0 now, which was empty. Okay, but we incremented it. Now I thought that incremented x0. Oh, I did an add. Okay. I guess I'm not clear what I'm thinking is going to happen. If you call start2d, I assume, what do you want to point to? And is 8 the right offset? Okay. I'm really... There is a way to dump memory. Let's see if we can figure it out. Memory read. Well, I think minus, no. Is there a range? Well, let's try. Well, what's weird to me, I guess we haven't executed the BLR yet, but x0 should be picking it. It should be executing this, I think. Not this plus 8. Okay, so I think you give start2d, you're going to give it... Well, no, that's not quite right. I mean, start2d should have the pointer to... I don't know. Should it have the pointer to itself, or should it have the pointer to the list? Yeah, x0 should be one of those two. Okay. Read x0 is pointing to empty. Okay, so it just called, I don't know, it just called 8. Is that offset wrong? Okay, let me try this mem read. Let's just see, whoops. See if we can see the contents of that address or some approximation. X20 is empty plus 8. That's already too late. Yeah, I'm thinking this. I think. No, x0 points. Okay, sorry. X0 points to the empty. That seems wrong. Oh, we incremented it. No. Yeah, wait a minute. I think this instruction, I'm reading it wrong. I think it says x20 equals x0 plus 8, but it seems like it's acting like an auto increment on x0. Because we didn't have x0 on the left-hand side of any of these changes, and we came in, it was pointing to the start 2D. I think. Let me run it again. Yes. Okay, so we broke at the beginning, read x0. It points to empty. That seems wrong. I don't know why we're getting the error, but x19, that's stacked. Nobody looks at it. x20, we want to be well. What's weird to me is, okay, we got x0 is pointed to empty when we get here. That is not what I want. I want x0 here. Where's my test? Yeah, this is my test. Okay, so we're loading x30. We're storing. Oh no. Okay, that should be the same as link register x30. Okay, so address 0, x0 gets 12. What the heck? ADR. Load address, x0 gets empty. Empty is in the data section. So I don't see how that can be right. Oh, that's test setup. There's our no op. Okay, here's loading x0 and the offset. Okay, so x0 gets empty. X0 empty. So we should see this 1824 thing again. Okay. Yeah, when we jump into run interpreter, I expect this to be pointing to empty. Maybe I keep mixing up empty and N2D. Okay, maybe I'm just being stupid. So we load x0 with the address at x19. Okay, so, all right. So we come in empty. I think when we run this, like, what's x20 versus x0? I guess that's my question. Okay, so I don't know where we are. Did we do a step yet? No. Okay. So if I do a step, okay, another step. Okay. Can I say x0 comma x20? No. Reg read x0. Reg read x20. Okay. Right now, x20 is start. What is that? is, well, let's go back to interpreter. We did the two stack ones. Run interpreter. Okay, so we're at this point. Before we do anything, x20 is that. Okay, I guess we step, and then we reg read x0, reg read x20. Okay, so x20 is now empty plus 8. Okay, so x0 is empty. So we're going to branch to x0 . Well, that is wrong. X0 should be the contents of empty, not empty. Okay, I guess we gotta... Okay, here x20 is the address of empty, just past the address of empty, pointing at the next statement. All right, so I think we're just missing a line here. Well, maybe it's not just, but I think we should say move x0 gets load x0, which is not a move, it's a loader. Load x0 with the contents of x0, which should be the method we want to go to, and then branch to it. And then we're doing this, add, that's simulating. Well, let's do it without it first. Okay, I think I'm reasonably caught up here. Okay, well, that's something. It's stuck. And that happened before when we didn't mess with the LR. Okay, so well, I should kill it before I go too far here. My room's a little cold, but no point running it. Okay, so I think we're branching to empty. The contents of empty, which should be start 2D, and then we're here. Okay, so let's now. We didn't get the bus error, so we've got something better. I don't know if that bus error is like you're trying to run code that's in the data segment, maybe. Probably should start writing down these errors and what they mean. All right, so what we got this before with the LR stuff. It's when we were doing it before we weren't calling. We weren't saving things on the stack, and it was getting all messed up. And so we were returning to ourself, and that sort of feels like the flavor of where we are now. But the start 2D is a routine that doesn't call any subroutines, so I don't see the issue. No, I don't think to return is supposed to do that. It should jump back to the link register. The print, that's in C-like, I think. Okay, so he calls other routines. He's got to do that. Oh, he restores the load LR. Yeah, because our normal prologue is store for routines that call routines. Store the LR when you get started, pop it when you're done. And this one's also storing x28 because we start using that as a temp. Okay. All right. Well, I'm going to break here. But we could, let's see. I think I have the ARM stuff up here somewhere. Preview. Yeah. This is that 6,000 letter file. If I get to the C section, I'm probably okay. Like 100 somethings. Still in the B's. I don't know, maybe the index would have been better. Okay, except conditional branch. Well, I'm going to use table of contents. May regret it. System instruction doesn't sound like us. I don't know if we're a base instruction. Storage data processing. Let's look for red space. That'll help. No, it won't. Ugh. How about BLR? Unconditional branch, BBL. Branch with length. PC plus 4. I think we're using plus 8 because we got 64-bit stuff. Okay. Oh, so this is semi-alphabetical? I don't know. I mean, if we're used to this, I mean, I think a ret by default returns to the LR unless you've done a ret with a different register. You don't have to use the LR, but when you do, it apparently somewhere they talked about giving hints to know things are subroutine calls and returns. So if you do a ret and you're not using LR, then you're probably getting a slight bit worse performance. Closing in. Here we are. Okay. Branches unconditionally to an address in a register with a hint this is a subroutine return. Okay. And then default is X30, which is the link register. All right. Yeah. Does the test mess with any register used in the interpreter? Well, I think we're setting 19 and 20, and 0 is the argument passed in, which seems to be the right it's pointing to empty, which is what we want. So I think we're okay. Now, I guess I want to break here and make sure we're where we are. We can look at the registers and the returns and stuff. So I think that'll be at least plausibly be interesting. Okay. Okay, so let's break, set, run minus B, run interpreter, and then break, set, minus B, start to D. Okay, and I'll run. I wish I could just say always. Okay, so we're breaking at interpreter. Well, I don't know, this start plus 28, I guess that's start here. I think that start is this, not start 2D, which is potentially confusing. 28 is 16 plus 12 is C, 1C. So D8, DE8, 3DE8 plus, well, let's do hexadecimal, 3E08 minus 3, minus 4, 3E04 minus 3DE8, 3DE8 equals 1C. Okay, so that is the right location. Is the test that breaks since interpreter changes registers also using the test? No, I don't think we're not getting to the test yet. I think we're, well, my hypothesis is we're stuck in ret. We've screwed up something and this ret is going back to the wrong place, but I may be wrong. Okay. But I think if we continue from here, we should get to the start 2D routine. Okay, which I hope that's where we are. STR30, no. Oh wait, yeah, that's where we are. Start 2D. And we're looking at the ret. That's an old, yeah, I commented that out. Okay. Yeah, we're looking at the ret. So let's look at X30. Reg, read. Can I just say RR? No. Reg, read, X30. Okay, start test 3E18. Well, we're a little funny, but that's a little funny. Right, so LR is where are you going to return to? I'm not even quite understanding this. So we branched to, well, let's look at X20. Read X20, that's our PC, is empty plus 8. Okay. So X20 is pointing at the right place. I think that it's 8 bytes later than then empty, which is the start method. But now LR, that seems really wrong. Yeah, like what? Okay, so 20 is empty plus 8. That seems fine. I lost my cursor here. Maybe I better plug in. Here we go. He seems to be where we want it. Let's look at X0. Read X0. Interpreter start 2D. Okay, so he has the address we thought. See, it's funny to me, like how LR, why LR is start plus 48. Oh, okay. Wait. That's not the same as start 2D plus 48. Okay. 3E18. Okay, I gotta run a new copy of this. I think we're trying to debug with old information. Okay, 3E18 is this. Okay, that seems okay. It says when you get back. Oh, yeah, that's where we're going wrong. Okay. I think. Well, we are, because we have a routine that's making a procedure call, and it needs to do the store SPX30 before and after. Okay. Yeah, so LR is not pointing to the VPC. It is pointing to this return. No, is that right? No, it's pointing to this return. Okay. Yeah, so because it made, so a BLR says store the LR equal to your instruction plus 4 bytes, one instruction down. So LR is pointing here, and then branch to wherever it says to go, start 2D, which does a return. Return says, okay, jump back to the LR. Return here, it gets here, and it says, okay, jump back to the LR. Well, the LR is here. That's why it's frozen. Okay, I'm getting better at spying this bug now. It's kind of the mistake I made on the first day, right? Because I didn't know how the procedures worked. And now I know, and I ignored it. Okay, which tells you something. All right, so our obligation, we have to do this on the beginning because we call other methods, and this on the end. Okay, I don't mind that space. Okay. So now when we get back here, the LR is pointing down here, but we're going to load up the new one that says go back to the test and call. Okay, so now I don't know if the test will pass because I mucked around with it, but expected token at start of statement 2616. Oh, I just bumped something, I guess. All right, I think this is progress. It's certainly better to fail than than to freeze up. Good. Okay, so our test asserted that the program counter had moved forward 16, and I had commented out this partly because I think it may be wrong. Okay. I think it should have been. I want to change that. Yeah, because I think what should happen is, I think Start2D should actually own X20, or it should need to save X20, just like it needs to save the LR. Because if you're, let me get back to my picture. Yeah, so if we're going through, we come into Start2D and we start walking. His job is walk through these and call their stuff. So we know he's going to have to save his LR and all that, because he may be calling other people who do returns, and then we'd mess that up again. So he does need to do that, but I think he also needs to store his PC, because say we're in this one and we get here and we call another secondary, and we're working our way through, and he gets to the second one, gets to the end of its list. Maybe it had 20 steps. We're on step 20. If we return, we need to be back here on step 3 or 4, wherever we were. So he needs to store that too. Now I think that's just normal business at this point. All right. So, but I think our assertion then, I mean, he should restore the X20 to whatever it was. And I almost think it's his job to start that in X0. I think we want to pass him, here's the address of your starting code. Now, many things may ignore it, but that's okay. So I think this X1, I think this should be maybe be X1 and branch to X1. X0 here, when he comes in, this way. The question is, what is the starting point for X Start2D? If he knows, he doesn't need to know his own address here. I think he needs to know this address. Now, regular code doesn't take any arguments, so it's going to ignore that address, but it wants to start there. The address of the code, we just want to start. We don't have to look at anything. So I think the N2D, in our case, the N2D was the only thing. So I think the pointing to that is the right thing. So the +8, I think, is correct. And I think this should expect it to be +8. This should expect it to be +8. Because the virtual program counter is going to be set to the start instruction of whatever block it's working on. Okay. So I think this should still pass. I think it should pass. I mean, yeah. Okay. I'm going to check that in. We've been read long enough overnight. So we create run interpreter, Start2D and End2D first test. Okay. Not much of an accomplishment in a way, but it gives us a framework to do things. Now, I think this, well, he certainly needs to do this because he's going to be calling stuff. There's no way around that one. Okay. And this should be neutral as well. I don't know if I need to check this in, but kind of make sure our refactorings are clean so far. Okay, now this, let's set. Well, no, it's kind of like what he's coming in with is x20. Oh, I'm confused. All right. So start2D. Let's say how he gets along. Start2D is starting point for secondaries. Okay, and his input is something, and his output is something. Okay. And then maybe his process is something. Okay. So he comes in. Is he going to have X0? Well, I don't know. I think when he comes in, X20 is the starting point of the secondary list. Okay. And then the output, I think he's going to I'm not sure. Okay. He should. Well, I don't know. Maybe his input should be X0. I guess that's the place I'm getting to. But it's really X20 at this point. So if he gets 20 pointing to his first thing to do, he should run through all those. Yeah, so, well, I would say it's the starting point, entry point to a secondary, because they're all going to have start2D, and they need something pointing, well, here or here, because either way they can work from one to the other. But his normal thing is going to be, hey, somebody gave you this list of addresses, go work on it. Okay, now assembly code is not going to touch those. He doesn't care about X20 because he just runs and does his thing. But then this thing somehow should do stuff, right? He needs to walk through that list. Yeah, the first thing to do, it can be either one. So if like the test I started to write that was way too big, right? That put in a bunch of primitives. Okay, but we haven't called. We haven't made a method out of this to do it. But I think once we have this, well, we need this interpreter to make that work. but yeah, so his job is pull out the address. Basically, he's going to run a counter from here down, or he's going to start an address here until he gets to here. He'll pull out an address. He'll say, okay, address, you're pointing to address of some code. Kind of just like the run interpreter, he's going to take the indirect on that and then branch to it, BLR to it. And that code, if it's assembly code, then the address points to its own code and it just runs the assembly code. If it's secondary code, the address of what he's pointing to is also potentially a secondary. If it is a secondary, he's going to say, okay, I'm going to point to your address, start2D, and go, start your list here and go. And so it's gonna act in the same way. They both have to act in the same way because Start2D can start either primary or secondary. But I think we know X20 is really for the benefit of Start2D walking through his list. It's not anything to do with the primaries, so they don't really need to worry about X20, but the secondaries do. And then I don't know. It's like trying to get that right is a little mind twisting, but I think we'll get there. But like doing this is like the whole heart of the project. Everything else is kind of around this. If we can interpret a primitive and we can interpret a secondary which contains primitives or secondaries, the interpreter is done. It's not a ton of stuff. Okay. So in here, I think the next step is X20 is coming in with that starting point. Is that the right thing for us? I almost think we want to say X0 is the starting point and you use X20 however you want. Okay. So let me do this. I want to store X20 at SP -8. Okay. And we've done this before. I think it was the print, right? Where's print? C-like. C-like. Print stores this at #8. Okay. So we've this stat grows down, ours grows up. So that's going to be confusing too. But they subtracted 16 and they put the LR back 2 slots, and then they stick this one back 1 slot. So it's pointing at the next ready to go slot. Okay. All right. But yeah, this is almost exactly what we need to do, except it's a different register. X20. Okay, so I think whenever Start2D gets back, his caller should restore X20. All right, and then this is going to be loader X20 from SP. #8. SP inside #8. Okay. Okay. So this points restores X20. We pushed it last and popped it first. All right. This should also be neutral to us because we weren't doing anything before. So make should still pass. Okay. And I think that just says Start2D is going to call stuff. We know that. We'll do it. Now, I kind of think, okay, I guess I'm puzzled. Yeah. Okay. I think we're okay. I think the caller is going to have to increment X20 when it gets the next step, but that's not our problem. Okay. So now I want to say, okay, what happens with N2D? Right. I think N2D, well, this is where it gets a little mind-blowing to me, especially. I think what this thing has to do is never return, okay? Because I think N2D has the job of doing the return. So I think this code is going to migrate down to N2D when we get things right. Okay, so what it should do at this point, and I think we're ready to do it. If we take X20, we know that was the address of N2D. I think we should be calling it doing this. Whoops. BLR X20. Is that going to be right? Okay. So I think X20, well, he's going to return and all that's going to be fine. I think this will work for what we have if everything's right so far. I believe X20 is coming in with the address of our second line, which is N2D. And so we should, is it X20? I don't know if it's if we have to do this LER thing again. X20 is the address of, okay, yeah, keep it straight. X20 is the address of this quad, but we want to call the contents of the address of that quad. Okay, so I think our job is really kind of like this one. We're going to load X1, except we're going to load X20. X1 with X20's contents, and then we're going to branch X1. Okay. All right. So let's see if we can make this make sense. So X20, we come in, it's pointing to this slot. We're going to save our LR, so we'll return back to our caller. We're going to store X20 so we can recover that. And then we're going to load X1 with the current memory location of X20, which is the contents of it, which is N2D's address. Branch to N2D, and that gets us here. We'll return and then do this stuff. Okay. I feel like this is on track. Okay. I'll run it anyway just to make sure. Okay. So I think that's good. Now is when I think it gets weird. I think this is this. And I think it'll still work. But this is kind of a bigger step. Yes. Okay. That's okay. So I guess I'm going to put a comment here. Eventually calls N2D. Now, okay. Right. Let's see if this, the comment doesn't change it. Okay. All right. I think this is the twisty little thing that is going to make this whole thing work momentarily. Okay. So, we have N2D now is responsible for the return. Okay. And with that, I think that's all that's justified by what we've done so far. I think there's a little more to do to start 2D. But I think this next test is going to be the thing that does it. Now this, I don't know, we're being too, well, there's probably a next test that calls one real method. Yeah, I think Start 2D needs to loop, and increment and loop. Okay. So yeah, more instructions is going to make that happen. I don't know. We'll try this. If it blows out completely, we'll try a smaller step. But I think we're kind of okay. So let's learn our lesson from this. ASCII 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. Dictionary. And there's add to. Okay. And then, okay. So we're going to load address. Okay. We'll load those 4 variables. We're going to store x0 is add to. We're going to store start2d. Good. Push is x2 is 2 later. Sorry, we moved down 1 with the 8. We're going to put in the address for x1 and move down 2, that's 16. Put in the address for x2 again, another push. Down 16, put in the address for add, go down another 8, and the address for N2D. Okay, I think that is correct. We're going to load the address of add2 in and run the interpreter. Let's make sure that's what we did last time. Yes. All right. And then the data stack. Okay, we got to do an assert. Put something in x1. Okay, so x1, this should be 1, push 2, add, you get 3, and then it's done. So we should have a 3 on the stack. Move x1 equals 3. Okay. Now the address of x0 has the address of the data stack. I think we need to do move x0 gets x0 because we want the contents of the data stack. Okay. Yeah. So this is a good sized test. I mean, and we could just test push, but I think we're okay. Well, the goal is this just works. Now, I don't know if it will. No, it won't because we don't loop. Oh, LDR. I keep doing that. Is that the right one? Yeah. LDR. This is move. Well, this one's LDR, right? 130 is LARX1. This one's doing the remote relocated load or the register load. This one should just be a constant. Oh, and we need a pointer to the memory. X2. Oh, no, we don't need that. We need... L, and I think I did TS. Now, it's funny to me, we don't have that move to here, which is a little weird. Okay, we'll come back to that, but on my note. Unknown architectural fix-up guide. I think that's an LDR. Do we have another test? I'm not consistent about that. Assert equals an AS unit. Oh, he's got his own message now. Okay. We did change that. Okay. Oh. All right. Interpreter test doesn't know about push or add. Should start 2D list contain the instruction strings and get the addresses from a lookup table. I don't think so. Well, at least my vision for the system working like this is that there, as you type stuff in or load it from a file in the long run, that it should compile them as it goes. I mean, that's the way the Forth interpreters I know work. So you'll do a define, and some symbols are like immediate actions, and they so like colon will define things, and it knows like skip over the next token as the name, and then take those things and start looking them up and putting the address in the look up the address in the lookup table and stick it as the next entry in the dictionary. And so I think I'll lean on that, but it would be a valid way to do it. It's just it pushes the lookup to runtime instead of how light of compile time it is. But yeah. Okay, we need to include core.o in our make file. Core tests. Wait a minute. Oh, this is interpreter. Interpreter test depends on core.o. And it hasn't till now, which is probably indicating something. Okay. I forgot to put it in my list as usual. Okay. Thought that was too good. Let's get this. Yeah, I also last night tried an experiment. I was hoping you could, at least some assemblers, you could put like they have text. You could put text 1, text 2, text 3, and it would assign it to different text sections. And then at the end, it would pull all the text sections together. I was really hoping I could put these statements on our test start macro. I was hoping it could take this statement, because it's derived from the name of the test, as a macro step. It could say, oh, jump over to the text2 segment and drop in a BL to that label, and then go back to the text1 section and finish all the test macro stuff. But unfortunately, this assembler does not support that. I had thought it would, but it definitely complained. Because I forget to do this. I forgot to do it when XUnit used to make you do this too, and I would forget it all the time. And yet another reason to see your tests fail before you see them pass, unless you're doing what I call elaborative testing things that should already work. Okay. Okay, fail. All right. I don't know. Has the time come? Has the time come to print numbers? Because I want to know what the failure is. What was our assertion here anyway? As 3. Okay. Well, we can get here. Well, I'm going to stick a handy label here. Temp. Okay, so we can set a breakpoint at temp now. Oh. Did I make? I did not. No? Oh. Go through everything in this again. There we go. All right, so now we run. If I option allow, will it? Okay, so we're ready. We're at X0, ready to look at X0. Try this experiment. Okay, good. X0 points to the data stack. Okay, we'll do a step. Reg R X0. And it points to push. Okay, interpreter tests push. Push. It seems like a word we shouldn't. We have underscore push. I don't know if it strips those. What's in front of this? Okay, we can't tell from here. I'm going to have to look. Okay. Here's start. I want to see the data section. Well, there's push, underscore push. Okay. Disassemble executables. Could be minus S. Yeah, we want printf or something simpler, but okay. Well, oh, there we go. Okay, there's my 10,000 things. Let's change that constant. Data section, 10400. Text. Unwind info. Oh, maybe it's giving me this as binary stuff. Text. 104,000 is data. What's before it? I don't know what that push is. Test. Okay, that's our field stuff. Okay. Well, this does not... Okay, let me see. I've screwed up this stack over and over. I wrote it down somewhere, right? Where is the stack pointing? Okay, I guess we did this step. Now we're doing this. Okay, stack pointer points to the next place to write. Okay, so we were looking at we need to look back 8. Well, it's kind of this. Okay. X0 data stack. What did I say before? X0 minus #8 because work stack grows the other way. And then my stack that's 10,000 things long, let's make that like, I don't know, 16 for now. Maybe 20 just to make sure the alignment doesn't depend on anything. Okay. So, let's try again. #-8. Oh. Yeah, for real use, it'll have to be bigger. But on the other hand, I don't know how much stuff you can keep track of, right? I guess if it's recursive, you could keep track of lots. Yeah. Okay. All right. Oh. Let's see what we're getting. All right. So let's set our break. -b temp. And then we'll run. Okay. LDUR. It must be some thing. Okay. Let's print X0. Data stack. Okay. We're at temp. We're loading this. I don't care about the 3. Okay. A step. Well, I'm surprised this isn't even a violation. Right? Because we just took away 8 from the data stack. It seems like that's as low as it can be. Read X0. Oh, well, sorry, I'm being stupid. Our 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 method's incomplete. We have to complete it. Okay. So I think what's missing is well, it has no contents, right? It's just jumping to N2D. It calls. Well, we left this. No. Any other routine is going to call a let. Okay, so I think we need to increment x20. Add x20 gets x20 plus 8. And then we need to branch back to loop. Well, call it L. Interpreter loop. Okay. Yeah, I'm not quite sure we're at the. I'm not sure we're handling our stack right, but regardless, we weren't looping, so we were navigating those instructions. They need their own chance to blow up. All right. So one of these called methods is going to call N2D, and it's going to do the return. So that'll be our exit out. Okay. So track what's happening. So we come in with X20 pointing to our first item. We call in directly. It returns to us. We add X20. We increment that by one step. And then we go back to the loop again. And now indirect off X20 is one further down in the list. All right. I hope this part works, because this is, I mean, it's cool, but oof. Okay, so we'll quit and make. Okay, now we're failing. But I think we're probably calling the right stuff, maybe. We got back where we're supposed to, so that's a good sign. All right, now we'll do RLL. Break set minus B temp and run. All right, and reg rx0 points to data stack. Yeah, now we're in a weird place. Well, step reg rx0 0. Okay, well, we're due for a break, so let's take a break. I think we may be having an issue with, are we writing to the right place for the stack, and is it pointing before it or at it or after or what? All right, see you in a few minutes, 3 or 4 minutes. Welcome back. All right. So we got a 0 on our stack instead of what we wanted. I have suspicions that we're not treating our stack right, but I think the thing to do is let's modify this a little bit. So instead of this one, I propose we move N2D up here and just test a push with data in it. Now, push probably does need to modify x20, which that's a good thing. All right. So let's make, okay, add 2 x0. Wait, why is x0? Oh, x0 is the address here, and we're storing through it. Okay. I seem like we're doing it right. I want to get to this second push, which is x2 here. Okay. I'm going to take these 2 lines out. Do I get this free? No. That'd be something Xcode could have done for me. All right, so now you push x1, contents of x0. Store x1 where x0 points plus 8. Push. And then you skip 2 and store x2. Wait, x1 is start 2D. Okay, yeah, push start 2D. Push, replace push. And that's the post increment. So it skips 1 to there, and we're going to put the n2D there. Okay. And then this should be 1. Yeah. Okay. And 217. Yeah, so it's got its own name first. Oh no, that's the address we're pushing through. Okay. I think these are useless because they don't get written, so it won't hurt anything to be there. All right. I don't think we're going to get a 1. And if we don't get a 1, it's pretty clear we're not going to get a 3. Okay. Right. I'm so very tempted to break off and do print numbers. We haven't dealt with a lot of loops before now. I guess we'll run this in the debugger. Let's see what the temp is. Break set minus b temp run. Okay. Print or reg read x0. Okay. Sounds like it didn't get pushed. Reg read x19. Oh. It is the right place to look. Okay. S 0. But if I subtracted, yeah, this is not correct. Okay. The stack pointer is pointing to the right place now. X start plus 8. But to get to the top of the stack, we need to look at... Oh no, is that right? Oh, data stack. Yeah, we're looking at data stack. I don't know if that's the most useful way to do it. I could see the argument for doing it so that the current value is at the top of the stack. And that's maybe what I'm deciding. Yeah. Well, I believe this is right. The data stack should point to the entry. I don't know if it's the best way to do this, but that's different. Okay. Breaks down. Okay. Print reg r x0, reg r x19. Okay, so we have bumped the stack forward. Step reg r x0. It's push. What's weird? It should contain a 1. Yeah. Push. Like, how did push get there? All right. Well, that means we got to look at some other code. This was supposed to be core. Let's look at core.s, I think. Here's our push. Okay. Load x0 equals the stack plus 8. Push data x0. That's post increment. So load x0. Well, let's look at push data. Push data store. Yeah, it should be there from the act of pushing. Okay, so we get x0. Okay, I think what we're trying to say, which I think is reasonable, is we're going to take the instruction register, and remember it was like push and then pushes data. So the instruction pointer is actually pointing at the data at this point, or is that right? I get confused. Maybe I want to look at interpreter tests. Okay, so we come in with x20 here, we call that, and then we increment. So it's got to be a pre. I think our program counter is not operating the way push assumed. Let's go up here. Okay, so we come in, it's pointing to the first entry. We branch to that, and then we add. So it's actually going to be offset from that. It's going to be +8. Actually, we want to pre-increment it. Well, I think we just want to increment it. Well, no, pre-increment's probably right. Okay, so I think push. Well, I am puzzled. We want, well, x20, it's too late for a pre. This has got to be a pre. we do want to increment it. Pound 8. Boom, like that. Okay, I don't know if I'm breaking a test. All right, so because this is the case of data that's not ever going to get executed. So this thing has to be responsible to update X20. All right, so he adds 8 to X20 and then fetches from it and sticks that in the X0. So that should be the next slot arithmetically or in our list. And then he push data on that X0. Let's make sure push data is right. Push data says store and then increment. So we're leaving it after, we're moving past. Yeah, so well, no, because, well, maybe. Incrementing here. Maybe we should. Maybe we should. Okay, if we change that, then I think we want to do this and take this out. Nice that it saves an instruction. X1 equals X20 and then add 8 to X20. That does seem good. So the PC is always pointing to the next thing to do. Now this one, it's loading it and then moving it forward. Okay. I think you got, yeah, I'll leave that comment for a moment. So everything other than this first one, well, we'll see. Okay, then it really is. Okay, so that just says our stack, our single one worked. Okay, this is good. I think that is, you know, I thought I even had that at one point. It wasn't doing it, but I was probably screwing something else up. Okay. So he calls this, yeah. Maybe even. Okay. So that's a nice tight little loop. It makes me wonder if we could just squeak it. Can we pull another instruction out? But too cool. All right. Now let's put this test back how it was. So I'm going to take these two off and then put this back to 3. Okay, so now we're trying to do our push, add, look. X0 data stack. Yeah. Okay, this should hopefully still pass. It is different. All right. This is good. Okay, so in some ways we're done. I don't think we really are, but we've proved that a secondary, well, basically this loop is doing what we want it to. Okay. And I think this note probably belongs up here. Note, this doesn't return. This has no return. It relies on N2D being at the end of the secondary list. Okay. And I think that note should take care of that. All right. I'll make and push this. Okay. Make start to D and into D handle full lists of, well, handle secondaries. Okay. Yeah, woohoo. Now the, oh gosh, the next problem I want to worry about, well, we got some refactoring to do. Let's do the refactoring. But the next thing I want to test is I want to test a recursive thing, but we've never done an if or any of that stuff. Okay. So yeah, let's move this stuff into its own file and then work on a print num, numeric print. I don't think I want to do printf equivalent just yet. I think print num will be fine. Okay. This needs to be interpreter.s. Now if I hit this, what do I get? Not really. I want an empty document, not an empty nib. Assembly file. Okay. Interpreter.s. Okay. I never want that junk. And interpreter tests. Okay. So we've got run interpreter. All this. Well, I guess I'll cut. But first we're going to do dot include bunch of stuff, dot global run interpreter, dot global start 2D, dot global N2D. Okay. And they are in the, let's do a text segment. Okay. And then we need the data segment for this. I might put the data segment first because it's smaller and people are manipulating it. Okay, I'll leave it 20 for now. Let me add to do change data stack to a bigger size. Okay, we developed a 1+2 secondary, and we kind of did this, but we're going to work on print numeric, and then we're going to check that secondaries handle recursion, which probably means we need at least an if. Support if, and if is really kind of goofy. because the control statements like if and while, they're built up. It's almost like while they're going, they tell you where to put where to jump and stuff like that. I don't know if we can do relative jumps just like ARM likes to do. Might be a better approach, but we'll get there. To handle recursion, we have to have at least an if not, because we can just if this return, if the leaf return that, and otherwise go bigger. Okay. And let's see what else for interpreter. Okay. Well, I think we want to say data stack is the runtime data stack pointed to by x19, which is VSP, and VSP points to the next place to write. I really want to think about that one. Okay. I'll leave it as a question. Should VSP point to the last element instead of next one to write? Next free slot. Okay. Anything else? Oh, we need to make a global out of that. I don't know if it's better to list all those up top or if you put them where they belong, or with the things they belong to. Okay. And I don't know this. I don't think I have a very fast repeat. Okay, just to break up the data sections. I wish I could bold some of these or something. Okay. Well, assuming we haven't messed up any. Oh, we need to get the makefile needs to deal with it. Depends on interpreter.s and all these macros. And this depends on interpreter. I don't know what I bumped. Interpreter.o. Because tests always depend on the thing they're testing. Let's move this one up. Demo depends on interpreter.o and then interpreter.out. Depends on interpreter.o. The out should depend on everything. Oh, we don't have an interpreter.out. Interpreter test.o depends on interpreter.o. Okay. No rule to make interpreter.s. I've seen this before. What did I do? Build failed. Yeah, I would say. Interpreter.s. interpreter.s.o.s, right? I can have that. Okay, select.o. Well, no, I guess it does come before the test. Doesn't hurt. It shouldn't affect makefile. Interpreter.o. Make sure I'm spelling is right. Interpreter.s. Interpreter. Depends on interpreter.s and the macros. Oh, I didn't pull the macros in, the includes in. From here. Interpreter.s needed by interpreter.o. What am I missing? Interpreter.o looks just like this one. Interpreter.o, spelled the same. Depends on its S file. Interpreter.s depends on the macros. Oh, it doesn't depend on this one. That shouldn't matter. Because that controls when does it run, not what does it do. Okay. I might even left this. No. No rule to make interpreter.s. Select.s doesn't have any special rule. Don't see any extra spaces. I mean, if I just put this, I shouldn't have to do it, but I don't know if it'll. AS, no directory interpreter.s. Oh, is it? I think Xcode was putting stuff in a weird directory at some point, and I had to adjust things. Okay, there's no interpreter.s. I think it's in 10th. Yeah, why Xcode? I don't know. All right, let's move interpreter.s to whoops. It only did this to 3 files before. I don't know why those 3 got moved. Now it's going to be confused. Okay. Yeah, I mean, I thought when I did these, I said create. Oh, did I say with folder? I thought I said like new group without folder. Oops. Ugh. Okay. Well, I have it over here. Interpreter.s. think that gets me the right one. Okay. It's probably because I created the project after I created all the files and ended up in the directory beneath it or something, but it's annoying. I'll probably remember it after I do it 10 times. Okay, I don't need this. This. And now make should work. Okay, make clean. Make. Since I screwed around with the make file. Move interpreter to a separate file. I'm not sure. Do start2D and entity need to be in the interpreter? They're maybe not. I mean, they're kind of. I don't know if they're a little coordinated with it. I mean, you kind of have to know this to make sense of this. The other thing to do, well, another test, we should run interpreter on a primary. Now we've tested start2D on a primary, so I'm not too worried. But still. Okay, so yeah, I mean we can move them if we decide. I don't think this is, well, my hope is this doesn't grow. We're pushing X20, right? So I don't think it will need to grow. But I don't know. All right, let me fix these tabs. Copying seemed to have removed them. Thank you, Xcode. Okay. All right, print numeric. Let's go back to C-like. I guess I can theoretically close these for a little bit just to feel better. C-like tests. Okay. I'm going to assume I'm going to create a new print num that prints a value in X0. Okay, so let's make a test. Well, I don't really do a test for these prints, do I? They will test themselves. Unit test demo, we can play with that though. All right. Well, let's start off like this one, but it's going to be print num. Print number. Okay, X28 gets 42. What is X28? I think it's just a temp. Oh, print hello? No, 4, 5, 6. What is 42? Does this thing hold the addressable string length is called? Well, I don't see why. X28. Well, we're just checking that it doesn't destroy X28, I guess. But we're not checking any of the printing per se. Okay. So I'm not going to worry about 28. I'm going to say move 13. X0 gets 13. I'll print num. And I won't do the asserts. This is just a little test driver for, I don't know, a little test thing for these others. Okay. Address 0, X0. Okay, let's... print number. Okay, and I don't really need to run these two. I guess I can just put this first. Okay, this is my little playground. Store cell, return. Okay. Print number. Put a number in there. We want to see it printed. Okay. All right. So C like is going to get print number. Okay, input is X0. Output none. Okay. Global print num. Okay, this should build. Well, it's doing nothing. We want to see this one. Print number. And it's supposed to print the pass surveillance. It didn't do anything. Okay. Yeah. All right. All right. All we do is return. Go down here. Okay. Yeah, I don't know. I don't know if I'm going to mess with hexadecimal. Well, we haven't done dividing yet at all. I know I have a chapter on that in that book. The Smith book I was working with. All right. So are we going to make a string? Well, you're right. Maybe decimal to string would be the right thing to do. And the other thing is the easy way to do it, print it backwards, because numbers, because Arabic numbers were written for Arabic that was written backwards to English, and we didn't reverse the numbers when we brought them over. So you got to write your significant digit first before you know it. Yeah, let's assume that, and that's a real test. Well, no, the register contains a value. We don't have to treat it as hex or anything. It's just a number. But dec to string, that's real. Okay, so let's put in a test for that. That's a C-like test. Okay. So test end. All right. So I think we just want to. Well, we have no string equal either. Oh, just going down that path of everything. All right. Let's make some data. P to align to. I guess that doesn't matter. To this. This is L data dec to string. I don't know if you should allocate your own buffer or it should do it. Boy, it feels like it can do it. It's not calling anything. All right, so we're going to move x0 gets 13. Move BL dec to string. And then assert Well, yeah, I think right. I mean, even 20 something, right, should be enough. It's, I mean, 64 divided by 3 is 21 and change, so 22 plus a 0 byte, but yeah, 32 bytes will do it. And I think it's okay if it keeps the buffer. It's not going to call anything else or anything like that. I guess the problem is making sure it's there, and I really wanted assert equals string, which maybe I just need a string EQ. Yeah, that's true. 32 is nice and even. And it would cover everything up to even binary if we needed it. Boy. Am I pushing another one on top? I don't have a move string. I don't have anything except string length. Well, let's make sure the string length is 2. I guess that's a step. Let's see. We get back the address of the string, which maybe it should. Maybe it should. I mean, you have to use this string right away. So maybe it is better if you own it. Yeah. I think that might be the case. Make it your problem. L dex string out. And then dot fill 32. Okay, so the x1 needs to be, well, I guess we got to do a loader adder. X1 is L dec2 string dot out. Okay, so you're going to tell it what number do you want to convert and where do you want to put the result. We'll call that function, and then at the end, well, let's assert that, I think Phil takes the value. I don't know if I put that in my notes or not. Assembly directives. Fill repeat size. Defaults, I think, to something more than a byte. I think it's 16 bits. And the value should default to 0. I think, well, let's, what's the least pain? Nothing's going to happen in 5 minutes except a decision. I guess one possibility is we write a string AQ method that's analogous to the C string AQ. That requires a loop, a byte loop kind of thing, like the example we had from this guy. He had this uppercase thing, and he used that load with byte, and he did compares. But of course, we could run 2 loops and get our own compare. I think that's the right thing to do. Okay, so let's start the next test. String EQ for empty strings. Test end. Okay. I think we're going to move data L string 1 is ASCII empty string, and then L string 2 is ASCII empty string. We shouldn't care about alignment. Text p2 align. And it's not move, it's ADR. X0 gets L string 1 empty. I'm going to change that name. ADR X1 gets L string 2 empty. BL string EQ, and then we're going to get back a Boolean 0 or 1, or 0 or non-zero, but 0 or 1 for our purposes. x0 gets x0, so x1 gets 1. We expect them to be equal. And then we'll assert equal. Okay. That's my test. I got 2 minutes to make it work. Okay, so let's get this put in as... Okay, so CLake will run our test for empty strings, which should fail because we're missing terms. No, we want /. Yeah, CLake LDexter P2 align needs its number. Okay. And then I don't know if that's unknown fix-up kind. Is that not how we load these? There's one. ADRX LTS knows. Wait, what does assert equal do? I feel like I'm losing track. Well, I certainly need... He does not look at x2. He only looks at x0 and x1. Okay. Well, that looks like a valid load to me. Here, XLS TS2. I mean, this is not necessary, but LDEC2 string out. ADR X1. Oh, that only works. That works because they're in the test section. Not for us. Okay. Well, we're going to stop there. We know we have some work to do next time. So next time is tomorrow, 2 to 4:30 Eastern or 7 to 9:30 p.m. UTC. We'll start with print num, and I think we're positioned pretty well. We'll add some if tests so that we can write a recursive routine, and then we'll do some checking. But I think we're in good shape. Getting through this interpreter, assuming we've done it close to right, is a big deal. I'm glad we got there. That's kind of a a very good milestone for things. Okay. It means if we hit all the dictionaries and all that stuff set, we theoretically could run now. You can't do much, but that's okay. We'll add more. All right. Take care. Have a good night, and hopefully I see you tomorrow or some other time. Bye-bye.